All right, to wind up the official part of Chapter 5, we're going to do Topic 6, which is dividing polynomials. Now I'm going to also do an extra one, Topic 7. This will not be included on your test or your final, but hopefully might be useful in preparing you for your next course, whichever course you're going to take, and some useful skills, and we'll go over that later. So we're going to divide a polynomial, and we're dividing here by a monomial. So what we do, if they're asking us to simplify or divide, and we have an example that looks like this, well, the key is here's our common division bar over our common denominator. Well, what we do is we separate our numerator items and put them over our common denominator, and then we simplify each of these terms. So in a sense, this is one term held together by the common division bar. That's a grouping symbol. But now by putting them over their common denominator, we end up with two terms, and we simplify each of these two terms. And here we're defining that C cannot be equal to 0 because these then would be undefined. So let's look at an example here. They have it worked out very nicely. So there's our common division bar. There's our common denominator. So we're going to take each item of our numerator, which are now, if we take away that, they become separate terms, separated by either a positive or a negative sign, and put them over our common denominator. Here we have to be careful of the signs. Here this is going to end up being negative, this one's going to be positive, and this is negative. Now notice what happens. We can start to cancel out. 3 goes into there once, 3 goes into there 4 times, and that's where our 4 comes, and we have our negative sign already. A to the first, bring it up, it becomes a negative 1. So there's our a to the second, and we finished that now. Here 3 goes into there once, goes into there 12 times. The a's cancel out, and we're just left with a positive 12. And then here something interesting happens. We have a negative sign, we said, yes. 3 will go into 3 once, will go into 15 5 times. So in the numerator position we have a 5, but the a did not cancel. So we have an a left in our denominator. So in a sense, if you go back to one of our first lessons, is this expression a polynomial? And the answer is no, because there is a variable in the denominator. So this is not a polynomial. So in a sense, there's sort of like two different definitions. The general word polynomial, that's thrown around easily, anything with numbers and letters and all that stuff. But the formal definition is, does it have a variable in the denominator? Then it's not truly that official definition of a polynomial. Anyway. Read this over. So we often refer to this as long division. And why is it long? Because it takes a long time to do. And for many students, this is a challenge. But we'll see how it ties in with the old-fashioned division that you don't do because you use your calculators. So you're going to divide 43 into this. You may recall this from elementary school. Well, you take the 43 and you see how often or how many times it can go into 72. Now, it can't go twice because that would have to be an 8 here. So there's a little bit of artisan styling going on here. So you try the once. Okay. Then you multiply this times that, get 43. Now, what are you doing here? Well, we know we're going to subtract. But the key is, in algebra, when we do this, this is positive. Now to subtract it, we change the sign. It used to be positive, now it's negative, and then we just add these unlike sign numbers, and we get 29. We then bring down the 5. Now we have a trial. We might guess 5, or we might say 6 if we're lucky. 6 times, and we go 4 times 6. Well, 3 times 6 first is 18, and then 4 times 6 is 24, and 1 is 25. There you go. So that's enough. And you couldn't take 7, would be too much, and 5 would be too little. You'd have to do it again. That's why calculators are great. I like them too. And then now what do? Well, we got a positive number, but we have to subtract. So we change the sign, and now we add, which is a form of subtraction when it's unlike signs. And we get 37. We bring down our 6. And again, a trial divisor here. And we're shooting for 8, since they told us that. 3 times 8 is 24. 4 times 8 is 32, and 2 is 34. But now what do? This is positive. We have to change the sign, and now we add. And we get a remainder of 32. Well, this is the whole process. So our answer then is this, with this remainder over 43. Well, we're going to follow basically the same process as you see when we go over it in our next few slides. So here they're outlining the method. We're going to divide, we then multiply, we then subtract, we bring down and repeat it until there's nothing left, and maybe comes out even if we're lucky, and a remainder if not. Well, it's a remainder. Okay. Now, they give us a little bit too much here. I wish they would have given us just this part here without this, so I could explain it. But since it's written out here, we'll have to go along with this. So, what number, how many times does the 7x go into that? So, one of the things students often have a problem with is what number are they going to put up here? 7x goes into this how many times? Well, a little trick I like to show the students is take the 28x squared right there, and then you're going to divide it by this. So 7 goes into there 4 times, and then you have an x. So there is your first term. So now you're going to multiply. 7x times this gives you that. Then you go 3 times 4x, that gives you that. Now what do? Well, you're going to subtract. Well, this was positive, so to indicate that you're going to subtract, you change this sign to a negative, change this sign to a negative, and now you add. Well, these cancel out. That's what you're looking for. So now you have a negative 12, and notice this is a negative 23. So you add these two up and you get a negative 35x. And you're wondering how many times, and you can just put this over on the side or do it mentally, will your 7x go into that? So 7 goes into there a negative 5 times. 7 goes into 7 once, goes into there 5 times. So negative 5x. Okay? The x's cancel out though, so we just use the negative 5. Now we go 7x times a negative 5 is a negative 35x. 3 times a negative 5 is a negative 15. And by the way, we brought down that negative 15. Now, what do? Well, to indicate subtraction, we have to change the signs. So this now becomes a plus, and this becomes a plus. So these cancel out. So our answer then is right there. Now, of course, they're showing us that, but I wanted to show you the process. And again, on additional exercises, I work out a lot of these. So if you want to see many of them done, or at least a few, we're showing you here the process. It's in the additional exercises that we work it out. And I also do the board work, the whiteboard work of the lesson as well, which I think is useful. Okay, now in this one, we'll use what they have here because, again, it's too cluttered. On the other ones, they don't show all of this. I work it out step by step. So again, you divide 4x squared by 2x and you get a 2x. Multiply these together, you get that. Multiply this together, you get that. Change the signs. That's what this darker blue here is showing. These cancel out. I add this up, I get a negative 20x. Divide that by 2x, I get a negative 10. Multiply that, I get a negative 20x. 7 times negative 10 is a negative 70. I change the signs. They used to be negative. I'm now making them positive. These cancel out, which is what I'm looking for. And this adds up to 78. So how do I write my final answer? Well, it's this plus, and you have to put this into MATLAB. Now, you don't need to write these parentheses down here because this division bar indicates that this is all under one thing. Now, it's not wrong to write them, but normally you don't have to. And that wraps up. Very short lesson. And again, watch the additional exercises of the board work where I go over this in much more detail.